Good day, grade 9 students, and welcome to our week 7 module for the second quarter. So this is entitled The Mole. The most essential learning competency for this week is use the mole concept to express mass of substance. And our learning objectives are explain what a mole is, use mole to determine the mass of a substance, and calculate the molar mass of a compound. So, as an introduction to our topic, in real-life situation, pieces of matter are quantified by finding the mass or by counting. Vendors would sell mango seeds by getting the mass and salted eggs by counting. This choice of quantifying goods is determined by convenience. It is easier to get the mass of rice grains instead of counting the grains. The same way that it is easier to count the number of eggs rather than get their mass. You do not buy eggs by kilos, but by dozen. To measure these quantities, mass units such as kilograms or grams, or counting units such as dozen are being used. In the laboratory, chemists want to measure the number of atoms, ions, or molecules in compounds. However, these things are too small and too many to count. So, how do they count it? They use the idea of mole to represent a certain number of particles. A mole denotes a collection of large fixed number of particles, such as atoms, ions, or molecules. It is defined as the amount of substance containing the same number of atoms as 12 grams of pure carbon-12. The symbol for the number of moles is small letter n, and its unit is mole. But how many atoms or molecules does a mole of any substance have? Amedeo Avogadro, an Italian physicist, pioneered the studies in counting atoms and molecules. He concluded that a mole of any substance contains exactly 6.022 times 10 to the 23rd particles. This is called Avogadro's number. The term particles refer to the ions, atoms, or molecules. So this means that 1 mole of any substance is equivalent to 6.022 times 10 to the 23rd particles. 1 mole of carbon dioxide is equivalent to 6.022 times 10 to the 23rd molecules of carbon dioxide. 1 mole of sodium chloride is equivalent to 6.022 times 10 to the 23rd formula units of sodium chloride. And 1 mole of potassium is equivalent to 6.022 times 10 to the 23rd molecules of potassium. Again, 1 mole of any substance, may it be an element or a compound, is equivalent to 6.022 times 10 to the 23rd particles. There are different ways on how we can compute involving moles. The first one is mole to number of particles. We also have the mass and mole relationship, and we have the molar mass. Let us start with the mole to the number of particles. The mole concept provides us with conversion factors that establish the relationship of the moles of the substance and the number of particles they contain. As mentioned earlier, 1 mole of any substance contains 6.022 times 10 to the 23rd atoms or molecules. Avogadro's number has a symbol of capital N. From this relationship, we can conclude that the number of atoms or molecules contained in a given mass of substance may be computed as follows. If the substance given is an element, so we have the following formula. The number of atoms is equivalent to the number of moles multiplied by the Avogadro's number. And since the number of mole is equivalent to the given mass divided by the atomic mass, we can use the formula below. The number of atoms is equivalent to the given mass divided by the atomic mass multiplied by the Avogadro's number. If the given substance is a compound, we can use this formula instead. Number of molecules is equivalent to the number of moles multiplied by the Avogadro's number. Or again, you can use this formula below. You have the number of molecules is equivalent to the given mass divided by the atomic mass multiplied by the Avogadro's number. We have here an example problem to help us solve using the formula given to us. So how many atoms are in 3 moles of sodium or Na? Let us first identify the given. You have the number of the moles, which is 3 mole, and Avogadro's number. We can use the formula of the number of moles multiplied by the Avogadro's number to find out the number of atoms of sodium. Let us substitute the values given to us. So that means the number of atoms of sodium would be equivalent to 3 moles multiplied by the Avogadro's number. You are going to cancel out the units, leaving the unit of atoms. So using your calculator, you can derive with this answer, 18.06. Or, if you are going to follow the significant figures given to us, you can move the decimal place 1 digit to the left, making it 1.806, but take note that you must add 1 to the superscript that we have. So instead of 10 to the 23rd, it will now become 10 to the 24th since you moved 1 decimal place to the left. Another example that we have, how many molecules are in 20 grams of sodium hydroxide? So we have the following as the given. The mass of sodium hydroxide is 20 grams. We can derive the molar mass of sodium hydroxide by adding up the atomic masses of the elements involved. We have another video clip on how you can compute for the molar mass of an element or a compound. And then you also have the atomic number. So we are to find the number of molecules of the sodium hydroxide. So we are going to use the following formula. Given mass divided by the molar mass multiplied by the Avogadro's number. Substituting the values, you will have this. And using your calculators, you will derive with this answer. You have 3.01 times 10 to the 23rd molecules. And that's it for our moles.